Hello there, I am Dr. C.N. Okolubo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello, thank you for joining me once again for another session of business statistics. And today, once again, we are going to look at another example of normal probability distribution. Let's quickly go to our workboard to see the question we are to deal with today. You're welcome. As you can see up here, we have example 4. And the question is, in a statistics examination, the scores were approximately distributed normally with a mean of 55 and standard deviation of 7. What is the probability that a student selected scored in the first case more than 58, second less than 65, third less than 40, and then third, then fourth we have between 60 and 70. Let's quickly start with our solution. The solution we're dealing with here is number 1. Let's have A here, and the question we have before us is to look at P x greater than 58. That's what we're looking at. And to solve this, we know that we have to standardize this value to have a z-score, and it's from the z-score we will use to get the probability in our normal distribution table. So to get the z-score, we have a formula as z-score equals to x minus the mean all over standard deviation. And this will give us x is 58, that's what we have here, that's a data point, minus the mean from the question is 55 divided by standard deviation of 7. So what do we have? 58 minus 55 will give us 3. So we have 3 divided by 7, so that our z-score will be 0.43. Now the next thing we do, having got this 0.43, let's represent these values in our normal curve. So right here I'm going to have the axis, and then this is not neat enough. Let's just draw it a little neater. Okay, so let's go back. Okay, so here at the center we have the mean, and the mean is 55. And then we're looking for values that are more than 58. 58 is going to lie on the right of this mean, on the right. Towards this side is less than 58 and 55, and towards this side is more than 55. So we're going to draw this value here and this line here, so that this becomes 58. Now we are looking for values more than 58. See, more than 58. So it means we have to shade all this portion of the normal curve. Now let's represent this also, this z-score. At the mean, z-score at mean is 0, and z-score at this point is 0.43. Now what we'll now do is to find the probability of this value on the normal distribution table. and then we're going to look at 0.4 under 0.03. That gives us 0.43. So please come along with me so that we can look at what we have as the value that we are looking for. If you follow me here, we have our 50% distribution table, and we're going to go to 0.4. Can you see that? 0.4, and then we will trace 0.03. Can you see that? What do we have? We have 0.1664. So this is the probability we're looking for at the moment. So let's come back to our solution. So we have z-score of 0.43. It's going to give us a normal value of 0.1664. But mind you, what we found now is the probability of from this mean point to this data point. That's what this represents. But we need to find from here to here to above 58. What we are going to do, since this half part of our normal table is 50%, and part of it is already 0.16. So what do we do to get this value to this from this point upward is to deduct 0.1664 from 0.5. 0.5 is 50%. So what we will do, we will say deduct from 0.5. So the answer is 0.5 minus 0.1664. So the answer in the end will be 0.3336. That's like 33.36%. So this is the answer of finding the probability of scoring 50 from 58 and above. Now let's check from our normal table. From the total table. We have two tables here. This first one is the 50%. The second one is the whole 100% table. Now let's look for 0.4. This is 0.4 here on the table. Now let's trace to 0.33. So what we have here is 0.6664. Now what we do with this 0.6 is this is the whole table. Now mind you, for us to have 0.6664, 0.5 has been added to it. So that's why you have 0.6664. So what we do in relation to what we have on the table is to deduct the 0.6664 from 1, because it's like this table represents the whole of the curve, the whole of the normal curve. So now what it shows that from here to this point, but the 50% table shows from here to this point. So whatever you get from the normal table, 50% has been added to it. So what you do is to have say 1 minus 0.6664, and you are going to have this same answer. Let's quickly go to number 2. Alright, let's go to the second part of our question. And then we have B here. We need to find less than 65. So write P, bracket X less than 65. The first thing we do is to standardize this value and find the z-score. And here we already have the formula, which is here, x minus the mean over standard deviation. So I'll just go straight to answer it here. We'll have 65 in this case minus 55 being the mean, divided by 7 standard deviation. And this will give us 65 minus 55 is 10, divided by 7. And when we find this, what do we have? We have 1.43. Let's now represent these values in our normal distribution, our normal curve. So we have this, and then coming down this way. This is the mean. The mean is at 55, and we're looking for those who scored less than 65. So less than 65 will be on this side of the mean. It's going to come here. We will assume it's somewhere here, and then x is equal to 65. And then at the mean, z is 0, and then this value is 1.43. Now, less than 65, where are we going to shade here? Less than 65, this is 65. So all of these parts of the curve will be shaded. So let's just do that. This is less than 65. Less than 65. All of these will be shaded. Mind you, part of this shaded portion is 50%. So 50% on this side, which is 0.5. But then what we want to look for from our 50% table is what from this midpoint to this data point. And whatever value we get, we add 0.5. 5.5 is 50%. So let's go to our normal distribution table and locate what this value will be. So what are we going to look for in our normal distribution table? We're going to look for 1.4 under 0.03. We will add that, so we're going to have 1.43. So we're going to look for 1.4 under 0.03. Come along with me as we look at our distribution table. First of all, we'll consult our 50% distribution table, and let's look for 1.4. Okay, this is 1.4, we've seen it, 1.4, and then we're looking for 0.03, and here this is it. Can you see it? 1.4 under 0.03, and what we have is 0.4236. 4236. So let's go back to our workboard and write this down. So Z score of 1.43 will give us 0.4236. 4236. This is the normal value. So now what do we do with this value? This is from here to here. We now need to add 50% to this. So add 0.5. This will now give us 0.5 plus 0.4236, and that will give us 0.9236. So this is the answer. The probability of picking a student that scored less than 65 is about almost everybody. So we have 0.9236. Let's confirm this value from our total distribution, the 100% of total normal table. Let's come over here and check for 1.4. This is the normal table. It starts from 0.5, but the 50%, look up here, starts from 0.00. So this is the 50% table, and the total one starts from 0.5. So let's now go to this 1.4 on the 0.33. What do you see there? You see 0.9236, which is what we got in the other answer. We got 0.9236. Let's go back to our table on our board and see 0.9236. This is like taking the whole thing to this point, the whole table to this point, and that's why your answer is this. So this is the answer. Let's go to the next one, the 3 or C part. we're looking for P less than 40. That's what we're looking for now. P less than 40. The probability of picking X less than 40. So the Z-score again will be that will be 40 minus 55 divided by 7. So what are we going to have? 40 minus 55 is going to give us 15. So minus 15 divided by 7. And that will give us what? Have you done that with me? That will give us minus 2.14. That's what we're going to look for in our normal table. Next thing we do is to represent this in our table, in our graph, or in our curve. We know that mean here is 55, and then we're looking for those that score less than 40. Less than 40 is going to be at what side of the mean? Thank you. It's going to be on this side of the mean. So let's assume this line here. So S is equal to 40, and then Z-score at mean is 0, and Z-score at this point is minus 2.14. That's what we have. Now we're going to where we're going to shade. The next thing we look at, where we're going to shade. We're going to shade less than 40. Mind you, it's less than 40. So this is 40 and less than 40. So we're going to shade this portion of the normal curve. So we're looking for those that score less than 40. The probability of picking anybody less than 40. So let's now go to our normal table and find out what we're looking for. Again, what are we looking for in normal table? We're looking for 2.14. 2.14 will be that we have to look for 2.1 under 0.04. So that will give us 2.14. Let's go to our table now and see what we have. Please follow me. We have 2.1. This is 2.1. And then under 0.04, this is 0.04. Okay. So have you seen it? This is 0.4838. 0.4838. Let's not forget that. 0.4838. We now go to we have Z-score of 2.14 is going to give us 0.4838. That's what we have. Now, but mind you, what we want is what we've calculated so far is from this mean to this data point. We're looking at those that scored less than 40. What are we going to do? We are going to deduct this value from 0.5 because this portion of our table of our normal curve is 50%. So but we found this to this. So what is going to be the value of this is to deduct this our probability from 0.5. So what we have is deduct 0.5 from 0.5 from 0.5. So we're going to have 0.5 minus 0.4838, and that will give us what? 0.162. 0.0162. 0.0162. So this is the answer we have. Now, the same way, if we go and check the total table, it's going to give us about the same value. But mind you, what's going to give us will be about 0.9838. So what we do, we are going to deduct that value from 1 because that's the total table up to this point. So we're going to deduct it from 1. Let's quickly go to our last question. The question is question D. We're looking for those that have scored between 60 and 70. Between 60 and 70. How do we write that in statistics? We have probability of 60 less than x less than 70. That's how I write it. So it means that we're looking at two data points, 60 and 70. So we're going to have two z-scores here. And from when we draw our normal curve, we're going to decide what we're going to do with these values. So right now, the first one is 60. So I will go straight away to answer to standardize it. So it will be 60 minus 55 divided by 7. What will that give me? That will give me 60 minus 55 is 5. 5 divided by 7, and that will give me 0.71. Please do that with your calculator. The next one, the other one is 70 minus 55 divided by 7, and that will give us 70 minus 55 as 15 divided by 7, and that will give us 2.14. This value is similar to what we have here. Please look at the board with me. This value here is similar with just the mirror version of what you have here, what you did have here too. Now, we now need to locate what we're going to do with our values. Let me now draw the curve. We have the curve here, and we have the mean value is 55, and 60 will be where? 60 will be on the right side, above 55. So we have 60 here, x is 60, and where's 70? 70 is also here. Interesting. 70 is also here, so they are both on the side. So where are we going to shade? We are going to shade between 60 and 70. We're going to shade between 60 and 70. That's what we're going to shade. So what do we do with these values? At z is 0, here is 0.71, and here is 2.14. What we're going to do with these values is that since both of them are on the same side of the normal curve, we were going to deduct the smaller from the bigger one, because what we'll find from here to here, and from this midpoint to this one, and then we'll find the difference so that we can know what the probability of selecting between 60 and 70. So we'll quickly write this down so that we don't forget. Z-score of 0.71, and then Z-score of 2.14. Permit me, I'm going to just reproduce this value here. We have 2.14 here. So this one is also going to be 2. This one is going to be this. It's the same thing, whether it's negative or positive. So I'll just quickly transfer this here, 0.4838. That's what we already have. So our task now is to look for 0.71. So let's go to our normal table. Come along with me, please, so that we can locate what we need to do. So we're looking for 0.7 under 0.01. So this is 0.7. Yes, this is 0.7. Can you see that? So under 0.01. Have you seen that? What do we have? We have 0.2612. 2612. So let's go back to our workboard and have this. We have 0.2612. So what do we do with this value? I said we're going to do the smaller from the bigger one. Don't mind that this is the way it is. So I found it. So we're going to have the answer will be 0.4838 minus 0.2612. So our answer will be 0.2226. So 2226. So this is the answer that we have for selecting a student who may have scored between 60 and 70, so it's just 0.22. I want to thank you very much for joining me once again in this solution of problem and solution finding on solving normal probability distribution. Please go through it again, revise it, and master what we're doing. When you're solving yours, please have, as you say, have your calculator with you, have a normal distribution table with you. You can download it online. You can check any good statistics textbook, whatever you need to do, but just practice this and get to know how to solve this problem. God bless you. Thank you very much.